Hello everybody, we're back again. So previously we have simulated the MA1 and MA2 models using the coefficients of data 1.1 and another MA2 we have data 1 is 0.1, data 2 is 0.7. Okay, so let's look at the result one more time. Basically we have simulated MA1 and MA2. So with the noise ZT, which is white noise, and the leg of 1 of the leg of 1, which is ZT minus 1. So for MA2, we actually have ZT minus 1 and ZT minus 2. So these are all the functions that have been used. Of course, subplot is just to compare the two graphs. Right? So ARIMA is the model specification. Simulation is basically the simulation of MA1 and MA2 for 3027 observation. Okay, so we can just run this one more time and have a look at it. And we compare with the actual returns of NYSE. So we end up to have several graphs here. So the first graph is, this is the actual NYSE returns. So these are the simulated value. So despite of, so if you get rid of or ignore, not really ignore. So let's say if you get rid of all the extreme values. So basically the fluctuation of the returns is quite similar to the simulated values. Okay, so the only difference is the extreme values. Okay, or so there are quite a number of extreme values compared to normal distribution assumption for our simulated result. So the coming simulation we like to do is the auto-regressive model. Okay, so for auto-regressive model, so we're going to have the era 1. So you have the psi 1 and psi 2 here. Okay, so this is the leg of the xt itself, leg 1 and leg 2. For era 2 is leg 2, era 1 is leg 1. So we're going to simulate this using the similar functions previously. Okay, so let's continue with this. So let's say we have simulation for era 1. So the phi can be defined by, okay, so this is model 3, model AR03 or AR01. So this is, so the same function ARIMA. So let's say the same specification constant set to be 0. Then instead of MA now we put AR. Okay, so the coefficients of AR. So let's say we put 0.1 as well, set to 0.1. Then the variance, let's say we put a similar variance, let's say 0. So this is our specification. So later we're going to generate the same set of random number. So now you have AR1 or AR01, AR1 should be okay. So we call the simulate function. So the series is model AR01. So observation, the same thing, 3027. Because we want to compare with the NYSE returns, which is the same value. So after that, we have a returns of figure to plot it, plot the AR1. So this one is similar to. So put the title also. So this is AR simulated. Simulated AR1. Okay. So this is another series. We just run it. Now you can see This is the AR1. If you compare with the MA1, they are actually quite similar to each other. Okay? Just that even the height of the fluctuation also is in between. Actually, basically the same. But somehow there's a property called duality property of AR and MA model. Somehow they are connected. For example, MA1 can be rewrite in the form of AR infinity, and AR1 can be write in the form of MA infinity. So this is the duality of the AR and MA models. So this is the simulated AR1. So you do the same thing for AR2 with two coefficients here. So you just need to do some amendment to this. So AR1, this one you're actually going to have two coefficients, that is 0.1 and 0. So how do you determine this data phi 1 and phi 2, or data 1, data 2, and data 2? So basically the sum of this variable must be less than 1.00. Therefore, the stationary property will still be there. So basically, if the sum of this is less than 0.0, less than 1.0, then the ARMA model will be still considered stationary. So that will be another part of the theoretical part of the ARMA models. So this one basically put 2. So this one you need to change it to 2, because you have a variable called AR101. So this is AR102. This is AR2. This is AR2. Great, this is AR2. So you just run this, and you can see the AR2 in the workspace again. So it's AR1, AR2, and so on. So you can see slightly different from AR1 and AR2. So the fluctuation basically become less intense because the AR2 and AR1 still influence the current returns, or RT, depends on RT minus 1. So this is so you can fine tune the data 1 and phi 1 and phi 2 in AR. So therefore it will follow the models you desire to be. But normally when you do estimation and modeling, you don't need to guess. So you can use the maximum likelihood methods under the numerical methods to determine the phi 1 and phi 2. All the coefficients can be determined. Okay? So this is just for simulation, where you can compare the actual NYSE returns and the theoretical one, which is simulated. So if I like to generate the ARMA model, ARMA11, then basically I'm going to have check. Okay, so this one basically, if I want to rewrite, so if I have a ZT, basically, let's say XT, so to be, let's say XT is equivalent to the phi of XT minus 1 plus theta ZT minus 1 plus ZT, then this will be the ARMA 11, leg of XT, leg 1, leg of 1 for ZT. Okay, so XT depends on the previous XT minus 1, and also the noise, leg 1 of noise, okay, including the ZT as well. So now you have one data and one phi to be simulated. Okay, the same model, the same ARIMA methods you're going to use. So for this one, basically everything will be quite similar, or you can just cut and paste this whole thing here. Just make sure that you because in order for others to read your code and for your own references purposes, then you should able to put the statement, and therefore it's easier for you to understand. Okay, so this will be two coefficients, 1 here. Okay, so let's say this is alpha 0 1. Right? So in this case, you have AR and MA. Let's say we just put 0. This is 0.3, okay, for the AR terms. So for MA terms, you can just MA. So let's say 0 0.6. Okay, 0.6. So this one need to cancel. What happened is AR 0.3 or the two common. Okay, so this will be okay. So then you have change this to ARMA 0 1. Then this is model AR and A, so A 0 1. Okay, so this is AR 0 1. This is AR A 1 1. Okay, great. So this will be the simulation for AR 1 1. Specification, you have AR terms and NA terms. So the sum of this is still also less than 1.0 to make it stationary. And okay, so just have a look at it. So it should provide something similar to the AR or individual. So this is AR and N. So you can actually see that it is quite similar to. They are slightly different. I think the intensity of the fluctuation is less compared to the pure AR1 model, because if involve more components, then the fluctuation will become less intense. Just like AR2 just now, you can see the fluctuation intensity actually become less. So this is of course depends on which models can provide you something to. If you do modeling, of course you want a simulated result which is following the actual series for this one. Okay? So the one fit the actual returns the best, then that should be the best model. Okay. Okay, guys. So basically, we have completed the simulation for MA models, pure MA models, pure AR models, and the combination of AR and A. Okay, so this will be the simple coding for it. Okay, hopefully you're able to understand a bit more about the time series, or in this case, financial time series. Okay, guys, bye bye.